Hello, everyone. A very good afternoon to all of you. First and foremost, if the audio and video both are fine, please let me know. Okay, wonderful. So let's begin with our session. In the last class, we had completed our chapter on energy and we had done a lot of topics in space technology. So these are the things that we did in the last class, and this is where we are going to begin from. So, first, we'll complete this part of our discussion with regards to space technology first, and then we shall begin with our next chapter, which is biotechnology. And after biotechnology, the next chapter that we have is nanotechnology. So these are the three chapters that we have lined up. So depending on how far we are able to reach, we'll see. Otherwise, after nanotechnology tomorrow, we might also go to the chapters of robotics and artificial intelligence. So first up, we'll start with space technology, and then we'll go to biotechnology. So these are the two important things that we are going to do in today's class. Now, the first topic that we have here in space technology today is Lagrange points. Now, Lagrange point as a topic has become a very important topic, and especially given the fact that it has been in the news constantly for one reason or the other. And that is something that makes it a very, very important topic for your examination. And especially, I would say, for your prelims examination, this is an important topic. Now, what are Lagrange points? Why have they become important? Why are they in the news? Let's try to understand all this. So now when it comes to Lagrange points, these are five special points. All right. These are five special points which are generated because of gravitation. Gravitation between two bodies, where one body is revolving around the other. For example, between the sun and the earth, there are five Lagrange points that are produced. Similarly, between the earth and the moon as well, there are these 5 points that will be produced. Between the sun and any other planet, these points will be produced. So these are 5 points which will be constantly these are 5 points which will be produced wherever you see any two body system where one body is revolving around another body. Now, in this particular scenario, these are the 5 points: L1, L2, L3, L4, and L5. These are the five special points which are produced. Now, why are these points important? There are certain missions that we have launched to these points. What are those missions? We'll try to understand that. And the significance of these points. Why exactly have we launched these missions to these particular points? Now, first of all, when we look at these points, understand why have they been in the news. First point is L1. Now, L1 is where we have launched our own mission, that is Aditya L1. So Aditya L1 mission has been launched here at L1. L2 has been in the news because another famous telescope, that is the James Webb Space Telescope, has been launched here. James Webb Space Telescope has been launched here. So that's why L2 has been in the news. And even L4 has been in the news, not recently, but rather in the last 2 years, we have seen that it has been in the news. And L4 has been in the news because this is where we found a new asteroid. There are Trojan asteroids that we found here. We found Trojan asteroids here. There are two Trojan asteroids that we found. One of them is 2010TK7, and the other asteroid is 2020XL5. So these are two Lagrange points that we have. These are two Trojan asteroids that we have found at L4. So that's why L4 also has been in the news. Now just understand all this, that what is the speciality of these points and why have we launched all these missions here. So Aditya L1 mission, what is Aditya L1 mission for? What is it going to study? Can you tell me first? What is it going to study? Yes, it is going to study the sun, and specifically the atmosphere of the sun, in that also corona of the sun is the most important objective of their study. Now, Aditya L1 has been launched to L1 because L1 is a point which is directly between the sun and the earth. If you see this, it is located right in between the line that is joining the sun and the earth. So that's why it is a point which will always keep facing the sun. And when it comes to all these 5 points, they will remain relatively stable, meaning that when the earth revolves, and let's say the earth goes from here to here, so now the earth is here, for example, then L1 also moves, and L1 moves to this point. L2 also moves, L2 moves to this point. L4 would also move, L4 would move to this point. L5 would move to this point. L3 will move to this point. So that's why all these points will be moving relatively. All right. All these points will be moving relatively. So that's why their relative positions will always remain fixed. So that's why L1 becomes a point which is always going to face the sun. And that is why Aditya L1 mission has been sent to L1. Because if, let's say, it was in a normal orbit like the low Earth orbit, it would keep revolving around the Earth. So it would come in front of the Earth, that is, face the sun, and then it will go behind the Earth and not have access to the sun. So this kind of an orbit is not the optimum orbit that we would want to use for a such a mission. So that's why Aditya L1 has been launched to L1, because from here it can get 24 hours access of the sun. Similarly, when it comes to L2, L2, as you can see, L2 lies behind the earth. Now, because it is behind the earth, it also means that it will never get exposed to any radiation from the sun. All right, it will never get exposed to any radiation from the sun, and that's why, in a manner, this entire earth acts like a shield for this point L2, because L2 lies behind the earth, and that's why sun will never be able to affect this particular point. So that is where we see that it becomes very crucial for us to understand the value of a point like L2, because when you are launching any space telescope, for that telescope to take very good observations, you need it to be protected from all the ultraviolet rays or the infrared rays and all the harsh radiations that are coming from the sun. So that's why earth acts like a shield when you are located at L2, and that's why L2 has been chosen as a point here. So that's why L2 for James Webb Space Telescope. Now, the concept of Trojan asteroids. On and off, Trojan asteroids have been in the news. Not only because of these two discoveries, but there are other missions that we have launched. There are other missions that have been launched. For example, there is another mission called as the Lucy mission. There is this Lucy mission that has been launched, and this Lucy mission is going to study the Trojan asteroids of Jupiter. It's going to study the Trojan asteroids of Jupiter. So for that, Lucy mission also has been in the news. Now, what are these Trojan asteroids? Right. So Trojan asteroids, in what sense do we use the word Trojan? You might have heard of the Trojan horse, uh, the story about Trojan horse. So Trojan is used when you are infiltrating something. So even there is, let's say, in case of computer malwares also, we talk about Trojan virus. So that Trojan also has a very similar approach, because wherever there is something which is infiltrating something, then in that case we say that it is Trojan. So now, in that particular sense, when we say that there is a Trojan asteroid, the meaning of Trojan asteroid is that this is an asteroid which has now entered the orbit of a planet. All right, it has entered the orbit of the planet and gets, you can say, uh, fixed with the orbit of a planet. It will keep on moving around with the orbit of the planet, and that specifically happens when they get stuck at a Lagrange point, because Lagrange points are relatively, especially when it comes to L4 and L5, these are stable points, that if there is something there, it can remain there for a very long time. It can remain in that area for a very long time, because of the gravitational effects from every side, that is, from the two body system. Mathematically, these points are produced. These are not imaginary points, remember this. These are not imaginary points or imaginary areas. These are real areas that you can calculate wherever you have a two body system like this, where one body is revolving around another body. So that's why this becomes very, very crucial for us to understand from this perspective, that why L4 and L5 also have their importance, because L4 and L5 relatively are very stable points. So that's why, let's say, what happens is, generally we know that all the asteroids are placed between Mars and Jupiter, correct? But there are chances that some of these asteroids will be dislodged. All right, they'll be dislodged from their orbit, and hence after that, what happens is that they would just keep moving around, and there's a chance that they might come near the earth. And in that sense, if they come to L4 or L5 for that matter, they'll just remain stuck there. They'll just get stuck there, and they'll remain there for a very long time. For example, the estimates for these two discoveries that have happened, of these two asteroids that we have found at L4 of the earth, the estimates are that for the next 10,000 odd years, they are going to remain at L4. 10,000 years they are going to remain at L4. So that's why these 2 points become important, because L4 and L5 are relatively very stable points. One lies 60 degrees ahead of the earth, and the other one lies 60 degrees behind the earth. So in this manner, L4 and L5 also become important. So when we say that it's a Trojan asteroid, the meaning of Trojan asteroid is, this is an asteroid that gets at one of the Lagrange points, one of the Lagrange points, and then move around the sun with the planet. So that's why these are called as Trojan asteroids. Now, just this is not an exact definition, but it's a simplified version of what Trojan asteroids is. So any Trojan asteroid will be an asteroid that infiltrates any orbit and gets stuck at that orbit and keep moving around with that orbit. Now, in case of Lagrange points, what we are saying is that these are points which where the gravitational forces of a two-body system produces enhanced regions of attraction and repulsion. And out of the out of the 5 points that we have, there are 3 points which we say that these are unstable points, and there are 2 points which we say that these are relatively more stable points. So that's why we see that this is how Lagrange points would work. And remember that their relative positions always remain fixed. So that's why when the earth moves, all these points also are moving with the earth. So that is basically what you see with regards to your preparation also, that when it comes to the Lagrange points, it is probably a representation of what is happening to a lot of your lives as well, that you are being pulled from all the sides and you are just stuck somewhere in between. And that is what Lagrange point is, where all these different celestial bodies are having their gravitational influence, and that is what is producing all these 5 points that are Lagrange points. Now, with regards to Lagrange points, a very important development has been Aditya L1, the launch of Aditya L1 that happened last year. And Aditya L1 has been one of the most complex missions that India has ever embarked upon. And hence, it is going to be one of the very, very important missions for India. Now, with regards to Aditya L1, one thing that is also worth understanding is that Aditya L1 is Aditya L1 every now and then will be in the news. And from especially from prelims perspective, you need to understand how to read all the information, how to understand all the information with regards to Aditya L1. Because every now and then there will be some news with regards to Aditya L1 that you will come across. So that's why you need to understand, you need to remember what to read and how to filter out what's important for your examination. Like, you look at this particular article that we have right here on your screen. Aditya L1 unveils full disk images of sun. Telescope aboard uses 11 filters to show new details. Now, this instrument, the name of this instrument is SUIT, SUIT, which is basically a near ultraviolet range telescope. So now it was able to take these pictures. All right, these were the pictures that were released. So these were the pictures that were taken. So there were 11 different filters that were put to get all these different pictures, and these pictures have been able to give us some ideas about solar flares, sunspots, etc. So that's why those filters were put, so that we can do the analysis in various different wavelengths. To do the analysis in various different wavelengths, we have been doing this experiment. So that's why this telescope and the images put forward by this telescope becomes very, very important. Now, in this particular regard, whenever such a news comes in, always just see what's the basic of that news. Never go into the technical details of this is what was done and this is how it got its images, and these are the techniques that were used. Not really required. Just stick to the basics of what exactly are we talking about. All right, so what are we talking about? And you can basically in just one line or just in two lines, the information that you can filter out about whatever instrument is in news. All right, whatever instrument is in news, just one or two lines about that will be more than enough for you. You don't need to go beyond that. So every time you'll see that something like this will keep coming in the news every now and then, so just take a look at it, and just in one line or two lines, just filter out all the information that you seem that seems to be important for you. That's it, nothing beyond that. Now, coming to the last orbit of all these discussions, and this is GTO, or geosynchronous transfer orbit. Geosynchronous transfer orbit, that's where the name GTO. Now, this is an orbit which is required to transfer the satellite from low Earth orbit to high Earth orbit. All right, low Earth orbit to high Earth orbit. Why do we need it? Because any launcher that we have, and we are going to discuss about launchers a little later, any launcher that we have, whether it's a PSLV or a GSLV or any foreign launcher also, whatever you know of, any launcher doesn't have the capacity to go beyond 2000 kilometers, maximum of 2000 kilometers. That's it. Beyond that, the satellite is on its own. The launcher cannot carry it after that. So what do? We use physics beyond that. We will provide it more thrust. There will be a scope of extra thrust that we keep, and so that this can be taken from low Earth to the high Earth. So first we'll see that the launcher will carry the satellite up to this point, and from there on another thrust will be provided. Another thrust will be given, so that now it gets launched to the higher point. So that's why from the low Earth orbit to the high Earth orbit. So we are transferring the satellite from the low Earth orbit to the high Earth orbit, and that's why this is called as a geosynchronous transfer orbit, because you are transferring the satellite from the low Earth orbit to the geosynchronous orbit. So, and why are we using it? I'll just write it here. We are using it. No launcher is capable of not launching, but rather carrying the satellite beyond a certain point. The GTO is designed to take the satellite from the low Earth orbit to the geosynchronous orbit. All right. So that is basically what we do, and this is where it has to be used. Even in case of Chandrayaan, etc., also you might have seen that this is how the launch happens. That let's say you have the sun and you have moon, and the satellite is to be carried between these two. So you might have seen that this orbit is something like this. That the orbit length will keep on increasing, and then it will be transferred. It will be transferred, and then it will keep on decreasing in its orbit, and finally it will land. So this is basically how any transfer orbit works, and there are different types of transfer orbits, and GTO is one of those transfer orbits where you are transferring the satellite from the low Earth orbit to the high Earth orbit. So this is basically what we do in case of geosynchronous transfer orbit. Now, the next topic that we have, a very very important topic, is launcher. But before that, if you have any doubts with regards to the two topics that we have discussed, any question with regards to the Lagrange points, or with regards to the GTO? Any satellite kept in any Lagrange point will revolve around the sun. Technically, you can say that. All right, technically you can say that, and that also is a point relate, because what happens is that, let's say if this is the Lagrange point, then the satellite will keep on actually rotating around this point while also revolving around the sun. So you have the sun here, and it keeps on revolving around the sun while rotating around this point. So this is how it will keep on going, like this, like this, like this. All right, so technically that's why you can say that. How the Lagrange points are identified. So identifying Lagrange points, basically it's a completely mathematical concept. You do that, you can calculate that on the basis of the mass of these two objects plus the revolution that these two objects have and how they are revolving. So based on all these things, you can do that. So the calculations are done based on all these forces and all the mechanisms here. What is the convention following, to follow the convention followed to naming of the asteroids? See, the convention that we follow is based on a lot of things. First, it's based on the size of the asteroid, plus when exactly the location happened, where exactly in the space have we located it. So depending on a lot of factors, these namings are done. uh, so what point of horizon that we located it in, so there are a lot of things that we take into account while naming it. Just to confirm, transfer orbit can be from low Earth orbit to high Earth orbit, or from one celestial body to another. Actually, both. All right, both are possible. What is slingshot? So, slingshot is basically when we take the help of any other celestial body. So, for example, let's say we suppose Parker solar probe. So Parker solar probe, from the Earth, it has to go to the sun, correct? But in the path also comes Venus. So what we do first is that when we launch this satellite, we first launch it towards Venus. Now what happens is that there will be a time when Venus will automatically, because of its gravitational force, start pulling it, right? It will start pulling this satellite towards itself. So now it gets pulled towards itself, and this is where we again provide it a thrust so that it can be taken away from here. So in a manner, half the journey will be completed without any help of any fuel, because Venus will be pulling it. So this kind of a concept is called as slingshot. Is there a chance that it falls inside the sun? I'm not sure in what context you are talking about this. What is the meaning of GTO? I just told you it is geosynchronous transfer orbit. If L4 can sometimes get stuck in the orbit, wouldn't Earth come? No, no, no. L4 cannot get stuck. Just understand this. Let me just go back again. What I'm saying is that all these relatively move. As the Earth moves, L4 also moves, L3 also moves. All these points will keep moving. It's the entire system that is moving. So it's not that anything will come in contact or anything will collide with anything. Why not the launches go beyond 2000 kilometers? Because of the amount of fuel that you need to even take it up to 2000 kilometers. So that's why it's practically not possible for you to have so much fuel that you can carry something up to 36,000 kilometers. Suit, I just told you that this is basically a way in which this is basically a telescope that we have, and this telescope is something that takes its images in the ultraviolet range or near ultraviolet range, and that's why it has been able to take all these pictures. And with regards to different filters that it has been able to take these pictures, and hence it has been able to give us some idea about solar flares and sunspots. What is nisar? Nisar basically is a joint mission between isro and nasa. That's why nisar is the name that has been given. And this is basically a telescope. This is a kind of telescope that a dual aperture telescope that india and that is isro and nasa are making jointly. All right, anyone, anything else? Ashish, if you have a relevant question, you can ask. The question that you have asked is not relevant to this class. Why L letter is used in this mission? Aditya, L1 because it has been sent to the point L1. L because of Lagrange, so hence L1 is the name given. Our satellite sent in these points. Yes, of course, that's what we are talking about. Aditya L1 has been sent to L1. All right, so let's move on. Now, coming to launchers, what we see is that these are vehicles. Launchers are also called as launch vehicles, and these are the ones that will carry the satellite to the required orbit. So, for that, you need a launcher. Now, when it comes to the Indian launchers, these are some of the examples of Indian launchers. But when it comes to Indian launchers, there are three brackets into which we can divide all the launchers that India has used until now: either historic or retired launchers, second operational launchers, and third future or the ones which are under development. Now in regards to when it comes to all these launches, the first category is of retired launches, where we have slv and aslv, which we do not use anymore, and hence these are retired launches. Second, we have the operational launchers, where we have PSLV, GSLV, sounding rocket, SSLV, GSLV Mark 3, etc. So all these are the ones which we are using currently. So that's why these are operational launchers. And then we have the ones which are under development right now, where you have the reusable launch vehicle, the scramjet engine, and NGLV that is coming out as a concept now. So we'll go into all these launchers one by one, trying to understand what these launchers are. First one that we have here is SLV. Now SLV stands for Satellite Launch Vehicle. All right, Satellite Launch Vehicle, and the first version of Satellite Launch Vehicle that we had used was SLV-3. Now in case of SLV-3, this was the first Indian launcher, and for the first time we showcased a technology that we are also capable of launching our own satellites. But this was not enough, because this was, you can say, more experimental in nature, test of technology more or less, where you had capacity of only placing 40 kg class payloads. That's it, only 40 kg. Now there was no concept of any uh, nano satellites or micro satellites back then. All the satellites, most of the satellites back then were communication satellites, and communication satellites are very, very bulky. They are more than 2000 kilometers, going up to 6000 to 7000 kilograms, not kilometers, kilograms. So that's why 40 kg was not enough, but experimentally we proved that okay, we are capable of launching our own satellites also. So this was back in 1979. Then after that came ASLV. ASLV stands for Augmented Satellite Launch Vehicle. Augmented Satellite Launch Vehicle, where we see that they have 150 kg class of satellites. They have a capacity of 150 kg class of satellites, and again not enough, because we most of the satellites being launched back then were again communication satellites, or if not earth observation satellites. And even earth observation satellites, they are at least 500 to 600 kg, up to 700 kg. So even they could not be launched with the help of ASLV. So both SLV and ASLV, you can say, they were stepping stones towards getting the operational launchers that we are using in today's era. Now, coming to the operational launchers, the first operational launcher is sounding rocket. Now, in case of sounding rocket, you may not even have heard of what sounding rocket is. Do you know this name? Have you heard of what is sounding rocket? Anyone who has an idea that there is something even called as sounding rocket? But then this will come to you as a surprise, this news. ISRO's RH-200 sounding rockets 200th consecutive successful flight happened 2022. So more than 200 launches have been done by this rocket, which you have not heard of. You might have heard of a PSLV or a GSLV, which are very often in the news, but sounding rockets are not. Right? Sounding rockets are never in the news, and there's a reason for that. Sounding rockets are largely used for experiments. We use them for experiments, whether it is space related experiments, testing of a component, testing of a key sensor, or maybe defense related experiments, climatic experiments, agricultural experiments. So we generally use them for these kind of testings and experiments, and hence we do not come to hear about them. That's why we don't hear about them at all, because this is where uh, we see that sounding rockets are usually used. They don't make the news as such, and many a times also because these are defense experiments, so it's not that the things can be said out in the open in the public about what exactly the experiment has been about. It is strategically important for India, and hence it will not be announced as such. So that's why you do not really know about a lot of sounding rockets, but sounding rockets have completed more than 200 of their launches. Now, in case of sounding rockets, we are saying that these are one or two stage sounding rocket, one or two stage solid propellant rockets, one or two stage solid propellant rockets. Now, what is the meaning of this one or two stage and then solid propellant rocket? Now, overall, when it comes to the sounding rockets, also understand the meaning of sounding rockets. That why we are saying that it is a sounding rocket. Do you know what is the meaning of sounding? Any idea about what is sounding? Hmm. Noise. So a lot of you have said that something related to sound or noise, but actually that's not the case, because when it comes to sounding, sounding in a manner also means probing or testing. So in a manner experimenting. All right. So this means testing or experimenting, you can say. So that is why the word sounding means to test, to probe something. So that is why the word sounding has been used for this kind of a rocket. Now we are saying that it is one or two stage solid propellant rocket. Now, one or two stage, when you see the use of this word stage, this word that is stage, the meaning of this word is that we are talking about how many compartments of fuels are there. Right. So it means that there is either only one compartment of fuel or there are two compartments of fuel. That is the meaning of the word stage. Solid propellant, meaning that the fuel that we are using is a solid fuel. So that is what we see with regards to these rockets. These are sounding rockets. Now coming to the most important launch vehicle perhaps for India, and this is PSLV, that is Polar Satellite Launch Vehicle. Now in case of Polar Satellite Launch Vehicle, it has been very important launch vehicle for India. There are a couple of reasons for it. One, it has been very successful. All right, it has been very successful, and that is why it has become very crucial for India altogether. At the same time, not only the fact that they are very successful, but they can be used for multiple different ways. They are versatile in that sense, that although they are polar satellite launch vehicles, meaning that primarily they are used for launching satellites into the polar orbit or the low earth orbit, but it's not necessary that you will only launch these satellites or these launch vehicles only to the low earth orbit. You can actually use it for other missions as well. For example, for launching Chandrayaan 1, PSLV was used. For Mangalyaan mission, PSLV was used. For all the IRNSS satellites, the Navik satellites, PSLV was used. Aditya L1 mission, PSLV was used. Astrosat mission, PSLV was used. So in all these cases, we have seen that PSLVs have been used. So although primary purpose for them is to launch a satellite into a low Earth orbit, but it's not that they can only launch the satellites into low Earth orbits. They can launch the satellites to other orbits as well. So that's why you have to remember that it's not about only the low Earth orbit, and that versatility that they have. Because of this versatility, they have become so famous. Also, because of the success that we have seen. Between 2007 to 2017, there were 40 consecutive successful launches which were done by PSLV. So that's why PSLV altogether also has been named as the workhorse of ISRO. Workhorse of ISRO. So important things about ISRO is, first, the success, then it being versatile, it being versatile, and at the same time also being very cost effective. So that is why is this polar satellite launch vehicle has been so important, because any big mission that we have, any big mission that we have for launching it, PSLVs have been used. Just that if the satellite weight is less than 1500 kg, it can launch satellites up to 1500 kg. So if you have a satellite which is up to 1500 kg, even going beyond the low earth orbit, chances are that we can use the PSLVs for launching those satellites. So that's why we see that PSLVs have become extremely important for us. And in this context, we have seen that there has been a lot of history. For example, this cartoon right here, this cartoon was published in the New York Times. The first cartoon that you see right here, this was published in the New York Times, where they're showing an elite space club, so-called elite space club, and then there is this person knocking the door. And when you have to, I mean, as a Westerner, if you have to represent India, just show that person with a cow. And for them, this is what India is. That everybody just roams around with a cow. Now, this is a pure case of racism. They don't want to understand where we are right now. Uh, they can't even believe that we can make a scientific progress, that India can reach the Mars. And this is where this cartoon was published at the time of the Mars orbiter mission, because it for them it was unbelievable that how is it possible that a country like India can even have a mission that can go to Mars. Forget about that. And Secondly, they used to say, uh, a lot of these articles would publish that India is a poor country, should not go to Mars. Instead, divert all that money for poverty alleviation programs to provide subsidies here and there. But we have to understand that when it comes to technology, and the spending on technology becomes very, very crucial, because when you spend on technology, this is where you are starting to look at a long term growth. When you're looking at something that will help you in long term, and not, it's not a just a short term story, or just a short term success. So that's why, if the countries, if you look at some of the European countries, or the US for that matter, or Australia, or China, Japan, Russia, you'll see that a lot of their growth story is also associated with their their expenditure on technology. That how they have spent on technology also has been a very important measure of the kind of development that we have seen there. So that's why we see that these all things become very important. And for the West, I mean, it's not only about India. Any country you take, India, China, Japan, other South Asian countries, African countries, West will never be able to digest the success of the East. They'll always feel superior. They'll always feel that we are not at the same pedestal as they are, and that's why these kind of cartoons. And that too, New York Times, supposedly one of the best media outlets of the world, is doing this. And it's that's why it's not only about that this government or that government. You might have seen that they have taken a huge anti-Indian government stance in the last few years, but you know about this because you are also preparing, and you also have now grown up. You go back and take 20 years back newspapers, or 30 years, 40 years back newspapers, you'll see the same thing. Whether this government, that government, any government, doesn't matter, they will not be able to digest the success of the East. This is what eventually it is. So they published this cartoon. Now our success answered this cartoon. We launched the Mangalyaan mission successfully. India became the only country to be successful to Mars in the very first attempt. No other country has been successful to Mars in the first attempt. Then the cost. It was the most cost effective mission to Mars. It was the cheapest mission to Mars. And not only the fact that it was cheaper than other missions, if you look at the per kilometer cost of the Mangalyaan mission, it has been lesser than what you perhaps pay to an auto rickshaw per kilometer. So so cost effective we were able to make it. So all that, I mean, that's why with our success we answered them. But then there was a wonderful cartoon that was published in the Times of India. This was published in the Times of India in 2017. That now it is showing that there is an elite space club where this person with the cow is sitting, and then all the other people who were sitting in that elite space club are now knocking the door, and basically showing this. It was about this record that India had made with PSLV C-37. This was when PSLV C-37 was launched. And PSLV C-37 launched 104 satellites in one single launch. In one single launch, 104 satellites, out of which there were only 3 Indian satellites and 101 foreign satellites. 101 foreign satellites and only 3 Indian satellites. So obviously, it also becomes a source of revenue. We generated a lot of revenue. Out of 101 satellites, 95 were US based satellites. So all that talks about the success of ISRO, and talks about the success of PSLV, and how important PSLV has been to ISRO's success story. The way, the confidence that PSLVs has have given also has played a big role, has contributed to India's success in the space sector. Now, in this regard, when it comes to understanding of the PSLV, there are 4 stages that PSLVs have. This is what, pardon my sketch, but just take this as PSLV. In the other class, I was just saying that ISRO takes almost 6 months to make a PSLV. I take 10 seconds to make a PSLV. So, so there are these 4 stages that you have in a PSLV. Now, in case of a PSLV, these 4 stages, understand what these 4 stages mean. you have a solid stage. In case of sounding rockets, we had discussed that they had only solid stage, right? In this particular regard, we are saying that there is a solid stage, there is a liquid stage, there is a solid stage, and then there is a liquid stage, alternatively arranged. And then this part is the payload. This part is the payload, or you can say in a manner, the satellite. This is where the satellite is carried. So solid stage, liquid stage, solid stage, liquid stage, meaning that you first have a solid fuel, then a liquid fuel, then a solid fuel, and then a liquid fuel. This is how the arrangement is when it comes to a PSLV. Now, in case of PSLVs, when we say that there are four stages in PSLV, the meaning is that first is the solid stage. So first stage is the solid stage, the second stage is a liquid stage, the third stage again a solid stage, and the fourth stage again a liquid stage. So first one is where you have HTPB based solid fuel called as hydroxyl terminated polybutadiene. Now you need not know the entire term, need not remember it, just remember HTPB. HTPB is the solid fuel that we are using in the first stage. And then in the second stage, where we have the very famous Vikas engine, we'll discuss about Vikas engine also later. You have the unsymmetrical dimethyl hydrazine called as UDMH, which is used in the second stage. And then we have the third stage again using HTPB. And then we have the fourth stage where we are using monomethyl hydrazine or MMH. So these are the four stages that we have in a PSLV. Now, usually what you'll see is that when it comes to any launch vehicle, whether it is a PSLV or any other launch vehicle, you'll always find that the first stage on in them is always a solid stage. First stage is always a solid stage. Do you know the reason, or can you think of the reason that why do we always use solid fuel in the very first stage? Can you just think of it? There is no negative marking. You can give me answers. Yes, Ashish, you have given the correct answer. Kola, you have given the correct answer. Anyone else who can think of a reason? So, when you use solid fuel, the thrust that you get out of solid fuel is more, meaning the force that is generated by the solid fuel is more as compared to the liquid fuel. And that is why when we are in the first stage, we use solid fuel, because first stage is on the earth, it is located on the earth. So obviously the gravitational pull of the earth is very, very strong on this launcher right now. So that's why you use solid fuel to provide that thrust so that this rocket could be launched. So that's why solid fuel. So first stage usually solid, because solid fuel generates more thrust than liquid stage or the liquid fuel. So that high thrust is required because you are located on the earth and you need to act against the gravity of the earth. So that's why this is how PSLVs are. So there are different variants of PSLVs that we use. Not really important for you to know about what these variants are and the technicalities of all these variants, but just see this variant, which has been the most widely used variant of PSLV. This is PSLV XL. This is the largest one, the bulkiest of the PSLVs. So that's why largely we see that in the bulkier of the launches we use it. For example, the first time it was used was for the Chandrayaan mission. This was the Chandrayaan 1 mission. This is the Chandrayaan 1 mission. And this last launch that has happened, this is the Aditya L1 mission. This is the Aditya L1 mission. So that's why we have seen that it is something that has been used constantly. And especially for the important launches, for the bigger launches, PSLV XL is the preferred variant out of all these other variants. Now, the second one is the geosynchronous satellite launch vehicle, or GSLV. Now, in case of GSLV, first and foremost, it does not have four stages, but does have only three stages. It has only three stages. Now, out of these three stages, and again, of course, you have the payload at the top. So this time you have a solid fuel, same as PSLVs, then a liquid, same again, but this time you have a cryogenic fuel in the third stage. We have a cryogenic fuel in the third stage. This is called as cryogenic. So this is where we are using cryogenic fuel. Now, whenever you come across this term cryo, the meaning, whenever you come to see this word cryo, it means extremely low temperatures. Extremely low temperature. So that's why cryogenic fuel is a fuel that works at extremely low temperature. Cryogenic technology is any technology working at very low temperature. So that is how we define cryo. All right. So when we say cryogenic, it means that cryogenic fuel is a fuel that operates at a very low temperature. So that's why it is called as cryogenic fuel. Now, when it comes to GSLV, GSLVs are used largely to launch any satellite which is bulky. To launch any bulky satellites, we would be using GSLVs. Now, when it comes to the bulkier satellites, this is where you need more thrust, you need more force to operate with, and that's something that is provided by the cryogenic fuel. Because initially, solid fuel works, but the problem with solid fuel is that solid fuel does not provide you a good control. A better control is provided by a liquid fuel or cryogenic fuel. So that's why, to have more thrust, we could have, you could say that why not just use four stages of only solid fuel, then you will have more thrust, so you'll not have to worry about all these other technologies. But the problem with solid fuel is that controlling solid fuel is extremely difficult, and hence we do not want to use it for the higher stages. And in the higher stages, that's why liquid fuel or cryogenic fuel will be preferred here. And this is where, for launching the communication satellites, we have this three staged launch vehicle called as GSLV. Now, the entire story of GSLV has been the story of the cryogenic fuel, because getting hold of cryogenic fuel hasn't been easy for us. It has taken a lot of time and a lot of effort for us to get the hold of cryogenic technology. And if you just trace back the history, we go back to 1970s first, where in 1970s, India and France used to cooperate on space technology a lot. And even the engine that we are using for our liquid stages, that is the Vikas engine, is something that we got from France. France has been using an engine called as the Viking engine. We'll discuss this also. So from Viking engine, we got the license of the Viking engine, and we modified the Viking engine to our requirements and made Vikas engine out of Viking engine. So this Vikas engine basically is used for liquid propulsion or liquid fuels, and is said to be one of the best engines out there in the world. Its performance has even surpassed the performance of the Viking engine itself. So now it performs better than the Viking engine, even after getting the license from Viking engine. So that is where we see that this is how geosynchronous satellite launch vehicle getting the cryogenic fuel has been extremely important. Now, in 1970s, India could have gotten this technology from France. France has asked for India's help scientifically and operationally, and said that in return we will give you cryogenic technology. This is 1970s. But back then we were also working on a lot of projects of ours, and it's not that we had that spare time that our scientists could go to France, spend 6 months there, and come back, because that would also have meant that we are going to lack in our space technology programs. So that's why we refused. We said that no, we can't help you, because we are also occupied with a lot of things that we are doing right now. So we could not help France in that project, and we could not get the hold of cryogenic fuel. Now, many experts believe that this was a strategic mistake, that India should have helped France. It would hardly would have, let's say, taken a hit of maybe 6 to 9 months of time, but that could have given us a gain of 25 years of struggle that happened in the next 25 years for India. Because from there on, it almost took 25 years for us to finally get the cryogenic fuel, or build cryogenic technology in India. But it's very difficult to say uh, that the scientists could also have known about this, that we could have strategized this better. We did not know that it is going to take 25 years. We did not know that this is going to be a big ask in the future. And back then, we did not even have a use for cryogenic technology. There were no aircrafts that India had that could use cryogenic technology. There were no launch vehicles that could use cryogenic technology. So we had nothing. We had nothing. So that's why it would be unfair to say that that we made a mistake there. Yes, you can retrospectively you can say that things could have been different, but to analyze that in the present is very, very difficult. So that's why we cannot really say anything on that. But it took a lot of time. Then in 1980s, I think in 1986, there was a US based company which was ready to provide us cryogenic technology, but at a very, very high price. So then we refused that. We said that we can't spend so much on getting this technology. And then, as usual, as always, came Russia. And Russia said that we are going to provide you cryogenic technology, don't worry about it. And it's going to be provided for free. And technology transfer also had happened, started happening between India and Russia, or rather USSR at that point of time. This was almost about the time when USSR was about to break uh, into Russia and other countries. So at that point of time, India started cooperating with Russia, and technology transfer started, but could not complete, because then there was this player which always has been uh, in the background for India, and this was US. And US did not let the technology transfer happen. And the reason was that US and Russia both were a part of Missile Technology Control Regime, MTCR. Both US and Russia were a part of MTCR, whereas India was not a part of MTCR. And according to the rules of MTCR, an MTCR country is not allowed to provide missile technology to a non MTCR country. So that's why Russia providing this technology to India was a violation of the laws of MTCR. And US said that, look, we are going to impose sanctions on both the countries if this technology transfer happens. So both the countries stopped. What else to do? And that's why that technology transfer could not happen. And this is when we also understood that we'll have to work on our own, and we cannot depend on anyone else to get this technology. And it took 10 odd years more for us to finally develop cryogenic technology. Unofficial reports also say that Russia might still have been helping India here, but you cannot know that. There is nothing official in it. So finally, by 2020, 2001, we got a hold of cryogenic technology. We understood how to use cryogenic technology, and this is where we started using our own launch vehicles for the bulky launches also. Because until now, if a communication satellite had to be launched, it would mostly be France who would do the launches for us. Otherwise, we did not have the capacity to launch our own communication satellites. But with GSLVs, with cryogenic technology, now we had the capacity, now we had the ability to launch these bulky satellites as well. Now, overall, when it comes to GSLVs, what we see is that there have been three variants of GSLVs that we have used over the years: Mark 1, Mark 2, and Mark 3. Now, in case of Mark 1 and Mark 2, you'll find that these are pretty similar, right? Their height is the same, lift off mass almost the same, number of stages same, payload that they can carry to the low Earth orbit same, payload that they can carry to the geosynchronous transfer orbit is also the same. So, so that's why these are very similar, because this technology was based on Russian technology. Mark 1 was when we were using Russian engine, and Mark 2 was when we made or modeled our own engine based on Russian technology. So that's why these two are very similar. Although we have seen a lot of failures with this cryogenic technology. When you look at the figures between 2001 to 2011, you'll find that more than half of the launches that we have tried with GSLV Mark 1 or Mark 2, they failed. But we were able to understand it and we were able to better the technology in the future. And hence we see that if you look at 2011 onwards, number of launches that have been done with GSLVs, you'll find that they have all been successful. Now we do not see it to be unsuccessful anymore because we have been able to stabilize it. And in this factor also comes GSLV Mark 3, where the height is a little shorter, lift off mass significantly higher, number of stages the same, payload capacity increases to up to 8,000 kg now, and uh, in case of the GTO, it increases to up to 4,000 kg now, which is significant. So that is how we see that GSLV Mark 3 is a significant departure from what is GSLV Mark 1 and Mark 2 and gives us a lot of functionality which were not possible with Mark 1 and Mark 2. Now, with this regard, many at ISRO also believe that GSLV Mark 3 should not even be called as a GSLV and instead let's call it as LVM3, Launch Vehicle Mark 3. And the reason is that cryogenic technology used here is different. All the other parameters technologically they are different. So with all these differences between Mark 1 and Mark 2 versus Mark 3, they believe that it's not wise to call it as DSLV Mark 3 and instead it should be called as Launch Vehicle Mark 3. So that's why whether you come across the term GSLV Mark 3 or LVM Mark 3 or LVM3, basically both are exactly the same, just that the name is being revised because we see that technically it is different, carrying capacity is different, cryogenic fuel is different, everything is different in Mark 3, and hence it should not be compared to Mark 1 and Mark 2, and that's the reason why they wanted to rename it to LVM3. Read this question, this was asked in your paper. I'll launch the poll for you after 30 seconds. Please read it meanwhile. I'm launching the poll for you. Please mark your answers. Good. Wonderful to see. 71% of you have marked the correct answer. Let me discuss this with you. With reference to India's satellite launch vehicles, consider the following statements. First, PSLVs launch the satellites useful for Earth resources monitoring, whereas GSLVs are designed mainly to launch communication satellites. This is fine. We discussed that PSLVs are largely used for remote sensing or Earth observation satellites, and GSLVs largely for communication satellites because communication satellites are bulky. So this is correct. Second is satellites launched by PSLV appear to remain permanently fixed in the same position in the sky as viewed from a particular point on the earth. This is wrong, because what we discussed is that in a PSLV, when you are in the polar orbit, it would complete one revolution in 2 hours. So it can't remain fixed. It can only remain fixed if it takes 24 hours, right? Because Earth is rotating in 24 hours, so this point should also move in 24 hours, and that which is that I mean that orbit, it is the high Earth orbit or the geostationary Earth orbit, where you launch the satellites with the help of GSLVs. So that's why this is wrong. It's not PSLVs, it would be the GSLVs. So that's why this is wrong. GSLV Mark III is a four-stage launch vehicle with the first and the third stages using solid rocket motors, and the second and the fourth stages using liquid rocket engines. Is this PS? Is it GSLV Mark III or is it PSLV? Because GSLV anyway has just three stages. It doesn't even have four stages. PSLVs have four stages in this arranged in this manner. So that's why the correct answer here will be only one. Then after this we come to Vikas engine, and Vikas engine, as I had just told you, that this is an engine which is a licensed version of the Viking engine that we got from France. So this is based on licensed version of the Viking engine which we got from France. And this is used in liquid propulsion. So whether in PSLVs, whether in GSLVs, whether in SSLVs, everywhere, wherever we have the liquid fuel being used, we'll see that this is the Vikas engine is the one that we use. All right. So, and as I also told you that this is one seen to be one of the most successful liquid propulsion systems in this world. Now, then we also have small satellite launch vehicle, a recent addition, an addition where we have seen that now ISRO is also trying to move into commercial space with small satellite launch vehicle. So, in case of small satellite launch vehicle, we have a three-stage launch vehicle where you have the three solid propulsion stages, and then finally we have a velocity trimming module, which is a liquid propulsion based system. So three stages, all three stages are solid stages, and then over that we have a velocity trimming module which is liquid. And that is why I talked about control, that solid stages cannot provide you that control that a liquid stage can provide. And that's why at the end, although it's a three-stage solid rocket motor, we see that still they are using liquid at the top to provide that control finally when you are keeping the satellite or sending the satellite to the required orbit. Now, obviously, when it comes to small satellite launch vehicle, it is capable of launching up to 500 kg satellite. That's why small satellite launch vehicle. Now, with this, what we see is, and as I just told you, that ISRO is also trying to move into commercial space, and there have been all these news in the newspapers. So this was July and September. ISRO to transfer SSLV to private sector. Now the plan here is that SSLV will be run and maintained by the private sector, and some private company will take it. So there will be there was a tender that was uh, given out, and a lot of companies, as you can see that there are 23 private companies which were in the race for SSLV technology transfer from ISRO. And that's why it is ever said, also being said, that it probably is the first ever example where a space agency anywhere in the world has transferred full design of a launch vehicle to the private sector. That a private company will start taking care of it. So this is where they are also trying to make a private space in the Indian market, in the Indian space sector. We see that it's not only about SSLV, not only about this particular uh, case, but there are other aspects of it also. For example, you will see that last year or even last to last year, a lot of newer launches that have been done by ISRO, it is not entirely all the parts that are used in it are not entirely made by ISRO, but instead there are some of the other companies which are making these parts for ISRO. For example, one has been the case of Bharat Dynamics Limited, and has been very famously in the news in the past 2 years, because how ISRO has been saying that they, I mean, a lot of parts which were used in the PSLVs, they were made by Bharat Dynamics Limited, and that's why Bharat Dynamics Limited became very crucial in that sense. So that's why we see that there are other companies also which are entering this market, and we see that there is a private space in the Indian space market also, or Indian space sector also, which is being created. A lot of opportunities also it comes with, not only about the startups and the new companies, but also a lot of employment opportunities that it opens up because of this market. So that's why we see that there are all these things here with SSLV. Now, coming to the future, and in the future, first important technology is scramjet. Now, in case of scramjet, we are talking about air breathing jet engine, which uses oxygen present in the atmosphere as oxidizer. Now, understand the meaning, that what do we mean by air breathing jet engine, first of all. So, air breathing jet engine means that there is a jet engine which, instead of carrying oxidizers, will use oxygen from the atmosphere as an oxidizer. Now, first of all, what is the role of an oxidizer? Why do we even need an oxidizer, that we are talking about everything around it? For any combustion to happen, you either need oxygen or you need something that can act like oxygen, can work like oxygen. Even if, and I had given you this as an example, that even if you are lighting a matchstick, then even lighting a matchstick is possible because there is atmospheric oxygen here, and then only you are able to light the matchstick. If there was no oxygen in the atmosphere, the matchstick cannot be lighted up. And hence it becomes very crucial for us to understand that it's not only about the fuel, but rather also the oxidizer. So even in the launch vehicles, or even in missile rockets, apart from the fuel, you need an oxidizer. Now, oxidizer weight itself in the launch vehicle is very bulky, it's very high. So because of that, because of so much of oxidizers have to be used, so fuel consumption also increases, your carrying capacity also decreases. It is not good environmentally as well, because you're using higher amount of fuel. So there are all these problems that we have, which can be solved with the scramjet, where we see that this is a supersonic combustion ramjet engine, meaning this is a kind of engine that will work at supersonic or even hypersonic speeds while using oxygen from the atmosphere, instead of carrying the oxidizers inside the launch vehicle. So that's why it will be able to increase the efficiency of the space launch vehicle by increasing the carrying capacity. So what are the advantages? One, it increases the carrying capacity, increases the carrying capacity, then uses less fuel, then becomes environmentally friendly, right? So there are all these important things that we see, and overall, so that's why we see that total weight of the satellite itself so decreases the weight of the satellite or of the launcher. So that's why scramjet, and that's why scramjet, and it's a technology that already has been tested by ISRO multiple number of times. The first time it was tested was back in 2016, and since then we have seen that there are smaller tests which have happened, even including last year. There was a test that was done with the scramjet engine, just to add to all the properties and just analyze all the various ways in which scramjet can be used. Now, when you look at the typical scramjet, this is what scramjet looks like. That there will be a space for inlet like this, so air will come inside like this, and then finally it gets compressed, air gets compressed, and because of this compression we see that we generate a lot of heat here, and this air which is already heated comes in contact with the fuel and helps in the combustion of fuel. So that's where fuel will be injected, it comes in contact with oxygen, starts burning, combustion starts, and hence the engine keeps on moving forward. So in this manner, we see that scramjet is a technology that can be used, but there is a limitation to it, because you need ample amount of oxygen. As you go away from the earth towards the atmosphere, concentration of oxygen also starts to die down. So it's not that you can really use it forever, correct? So only for the first stage we can make the use of the scramjet. Otherwise, by the time we are in the second or the third stages, oxygen levels have gone down, and that's why we do not have enough of oxygen to work with scramjet anymore. All right, but for at least for the first stage, it becomes a crucial technology. Now, going forward in it, we see that there is another technology that has been tested multiple times by ISRO, and this is reusable launch vehicle, where we want to reuse the launch vehicle for multiple launches. And here also, the first successful experiment that we did was back in 2015. In 2015, the technology was tested, and now we see that it's a technology which is under construction. And again, last year, 2023, also there were certain tests which were done with the reusable launch vehicle. So we are expecting that very soon these technologies will also be used by ISRO in any upcoming mission. So RLV has been tested like this, that while launching the satellite will be launched, and the launch vehicle will fall back. The launch vehicle will fall back, and the launch vehicle will fall back, as you can see here. And then after that, this basically can be carried back and it can be reused. So that is again a technology that has already been tested by ISRO, and that's why in the future we will see the implementation of RLV also. And this is where we see the implementation of RLV, where the concept based next gen launch vehicle is now in talks. Last year we have seen that couple not only last year, 2022 onwards, uh, scientists at ISRO, they have been talking about the next launch vehicle. They have not really defined what this launch vehicle is or what the name of that launch vehicle is, but it is a launch vehicle which is in the news, because they are saying that now they are also working on a three-stage launch vehicle, which is going to be a reusable heavyweight, which has a capacity of 10 tons, meaning that it has a capacity of 10,000 kg to be carried to GTO, which is huge, because with GSLV Mark 3 or LVM3, we have a capacity of only up to 4,000 kg. And here we are saying that we'll increase this capacity to 10,000 kg with the help of this next generation launch vehicle, where they also have said that they might use a semi cryogenic propulsion. Semi cryogenic is where you mix kerosene with cryogenic. So again, a technology that was tested last year in March 2023. This technology also has been tested. So all these are indicators that yes, now they are working towards this next generation launch vehicle, which will replace the operational launch vehicles of today. It will also mean the replacement of PSLV and the GSLVs. And instead of all these, we might have only one launch vehicle, that is the NGLV. So we still have to see that various developments that happen in this particular scenario. And then lastly, coming to the fuel. So when you look at the fuel, we discussed that there are multiple different types of fuel. So you have HTPB, or hydroxyl terminated polybutadiene, which is the solid fuel, right? This is the solid rocket propellant. And where do we use it? This is used in the first and the third stages, of PSLVs, and it is used in the first stage of GSLVs, and all three stages of SSLV. So this is where HTPB is used. Then after that we have UDMH, that is unsymmetrical dimethyl hydrazine, which is the rocket propellant liquid in nature. So now in UDMH we see that this is used in the second stage. It is used in the second stage of both PSLVs as well as GSLVs. So both in the second stage of PSLVs and the GSLVs, we are using UDMH. Then we have MMH, which is used in the fourth stage of PSLV, and then in that case again, also in the velocity trimming module, we discussed about the velocity trimming module in SSLV. So in SSLV, in velocity trimming module, we are using MMH. So that's why there are all these different types of fuel that we are using. Plus there is also liquid hydrogen and liquid oxygen. Liquid hydrogen is basically used as fuel in the cryogenic engine, where we obtain liquid hydrogen at minus 250 degrees Celsius, and liquid oxygen is used as an oxidizer in cryogenic engines, where you get this at minus 150 degrees Celsius. So that's why liquid hydrogen and liquid oxygen, they together they make up the cryogenic technology. They make up the cryogenic fuel. They make up the cryogenic fuel. And then after that we have MON, which stands for mixed oxides of nitrogen, which are used as oxidizers. Right? These are used as oxidizing agents or oxidizers in rocket propulsion systems, whether with solid or with liquid fuel. So we use MON in both these cases. In cryogenic fuel, we don't need it because liquid oxygen does the job, but in others, we need the mixture of oxides of nitrogen so that this job can be done well. So this is about all the different types of fuel. Any questions if you have? Any questions from here? So if VTM is considered, then SSLV will be four-stage vehicle. I wouldn't say that because it's not a stage, it's not a proper compartment of fuel, but a small amount of fuel which is used alongside the satellite, and it will just ensure that the satellite is taken to the required orbit. It is set in the required orbit, so it's not a big compartment. That's why we cannot call it as a stage. It's a very small amount of fuel. Lift off weight means weight of launch vehicle? No. When we talk about the lift off mass or lift off weight, lift off mass, this basically includes the mass of the launcher plus all the fuel that you are using, plus all the oxidizers that you are using, plus all the instruments, etc., which are on board, plus the weight of the satellite itself. So all these things, when you consider everything that is being launched, will become the lift off mass. In scramjet, oxidizer can be avoided in first stage. Yes, largely in the first stage, because by the time you move to the second or the third stages, oxygen concentration in the atmosphere is low. So that's why it may not work effectively as it works in the first stage, because then you are at the lower stage, a lower part of the atmosphere. Difference between scramjet and ramjet. Does it have to do with supersonic and hypersonic systems? You're exactly correct. This is what it is. That scramjet is when the speeds are higher in general with regards to as compared to the ramjet system. So that's why you can say that it's a better version of ramjet. While liquid fuels are varied from one launcher to another, it depends on a lot of requirements and the kind of thrust that we need to produce. So, depending on all that, we take these decisions whether we want to use this or that. So, usually, when you need higher amount of thrust from a liquid fuel, we use UDMH, and when we need lesser thrust but better efficiency, then we use MMH. So there are small technical differences in all these, and that's why we see that there are different fuels that are used. On GSLV slide, the image provided by ISRO explain that what is at the side of GSLV 3. Okay, let me just go back. Hmm. So basically, when you look at this entire structure, this is basically the support. This is just the support. This is where you have the payload. Then these are the stages. You have one stage here and then the other two stages here. So all these are the stages. And then on the side, this and this, these basically are also called as strap on motors. They are called as strap on motors, or they are also called as boosters. They are the ones that will provide extra thrust. All right, they will provide the extra thrust that it needs. And this part is also called as the core, or the base of the launch vehicle. Yeah, anyone, anything else, any other question? All right, let's take a small break here, and then on the other side, let's continue with our discussion. We'll discuss the last part of our discussion on ISRO, and then this chapter will be over. So right now the time is 1:29. So let's be back by 1:40. Let's be back by 1:40 p.m. and let's do the discussion on ISRO. Welcome back, everyone. Now we move on to our next topic, and this is about Indian Space Research Organization, or ISRO. Now, when it comes to ISRO, and when you look at every scientific development that has happened in India, probably out of everything, space research, space science, space sector has done the best. And no other sector can come close to how much we have been able to achieve in the space sector. So that's why when we look at from this perspective, we can always also give a lot of this credit to ISRO and how ISRO has functioned over the years, and all the scientists at ISRO who have worked over the years in making all this possible. Now, when we look at Indian Space Research Organization, the very first thing, if you look at the vision statement itself, it says to harness space technology for national development while pursuing space science research and planetary exploration. All right. So now, when we look at harnessing this technology for national development, now it has been well established that look, we are going to use space technology for national development, agriculture, communications, navigation, climate change studies, mineral and resource studies, border management, internal security. There are so many ways in which we have been trying to use the satellites, right? So that's why national development becomes the primary goal of everything that ISRO has been trying to do while pursuing space science research and planetary exploration. That on the side we are also going to do this, and that is something which is pretty visible also. That if you see uh, how exactly ISRO has been functioning, if you look at all these kinds of missions that ISRO had taken: Mangalyaan, Chandrayaan 1, 2, and 3, Astrosat mission, Aditya L1 mission. These are the only six missions that we have launched, which you can say that they are related to the pursuing of space science research. Otherwise, all the other launches that we have done, all the other missions that we've taken, all these missions are only and only related to national development in one way or the other. And that's why this one statement, the vision statement, becomes extremely crucial. That even if, let's say, you have a question in your GS3 paper or even in your essay paper related to science in India, related to space technology or space sector in India, in all these cases, if you can use this one sentence about the vision of ISRO, it will always help you get better marks and get the best out of the answers that you're writing. Mission statements are not that important. It's basically about everything that ISRO is doing: design and development of launch vehicles, design and development of satellites, design the all the INSAT satellites, all the GSAT satellites, all the remote sensing satellites. So everything that ISRO has been doing, it just has listed out everything. So missions are not that important, but that one sentence of vision is extremely important. So that's why I would want all of you to remember this one sentence. It can help you, especially in your mains examination. So yes, mission, as you can see, design and development of all the launch vehicles and related technologies, of the satellites, the INSAT satellites, the Indian remote sensing satellites, the use of applications for societal development, and space science and planetary exploration. So in all these cases, we see that this is where uh, ISRO has been doing a lot. Now, overall, when you look at the organizational structure of ISRO, this is also very, very important. And to understand everything that ISRO has been doing, this is where we get our understanding from. So, if you look at all the things that ISRO does and all the units that are there at ISRO, out of all that, especially this one line, all these units are very, very important. All these units, as a part of ISRO, they are very important. Apart from that, I would say these two are very important, and then here in space, these are very, very important. And just to know about them in one line, that this is what they do, this is what they are for. All right, so just knowing that much is enough for you. Now here, when we look at all these units, first to start with, you have Vikram Sarabhai Space Center, and the all the full forms are also given here, so nothing to worry. Vikram Sarabhai Space Center. Now, Vikram Sarabhai Space Center looks after the design and development of all the launch vehicles. Design and development of the launch vehicles, will be done by Vikram Sarabhai Space Center. Then we have LPSC. LPSC basically is Liquid Propulsion Systems Center. So LPSC is related to the fabrication of the fuel, especially the liquid fuel, but in general, all the research and development with regards to fuel will be done at Liquid Propulsion Systems Center. So this is concerned more with fuel fabrication. Fuel fabrication. Then we have Satish Dhawan Space Center. So Satish Dhawan Space Center basically is where we do all our launches from. So in a manner, this is where you have the launch pads. So this is the launch base. This is the launch base infrastructure of India. So all the launches are basically done here. Then after that, we have URSC. URSC stands for UR Rao Satellite Center. Earlier, it was also called as ISRO Satellite Center or ISAC, but now the name has been changed to UR Rao Satellite Center. And as the name itself tells you, this is where the design and development of all the satellites are done. So, all the satellites development will happen here. Satellite development will happen at UR Rao Satellite Center. Then we have SAC, Space Applications Center. Now, this SAC is where all the smaller components, instruments, sensors, all these things are actually designed at Space Applications Center. So that's why this again becomes an important unit, because all the smaller instruments, sensor design is done at Space Applications Center. Then we have NRSC, that is National Remote Sensing Center. So, National Remote Sensing Center is where we collect all the data that we get from our remote sensing satellites. All right, we get all the data from our remote sensing satellites, which is kept here. So, this is related to processing of remote sensing satellite data. This will be done at NRSC, that is National Remote Sensing Center. And then lastly, we have HSFC. Now, HSFC is a new addition. All right. So, compared to all the other units, all these other units have been here for a very long time. But compared to that, HSFC is a new addition, and it was only added in 2019 as a unit. It was added in 2019, and this is called as Human Space Flight Center. HSFC, Human Space Flight Center. The Human Space Flight Center basically is about taking care of all the human space flights that ISRO is planning. So this basically is related to the human space flight. So this is management and operations of human space flights. So right now, for example, the Gaganyaan mission. So all the planning with regards to the Gaganyaan mission is taken care of by this unit, and that's why in the future also this will be the one taking care of all these. So Human Space Flight Center. And then we come to Antrix and NSIL. Now Antrix and NSIL, these two are units which are also called as commercial arms of ISRO. These two together, these are called as commercial arms of ISRO. Commercial arms of ISRO. Now, why they are called as commercial arms is mainly because everything related to revenue generation, marketing, anything where money is involved, All these things will be taken care of by these two units, that is Antrix and NSIL. Now here, Antrix has been here for a very long time, almost more than 20 years now, easily more than 20 years now. Antrix has been here. NSIL is a new addition. NSIL was brought into the picture in 2019. Now, when NSIL was brought here, it was, or NSIL was added to, you can say, the organizational structure. It was also, it also raised a few questions that if we had Antrix already, what was the need for NSIL? Why did we even need NSIL? To this, the government had replied in the parliament, saying that look, Antrix is going to be supply based. Antrix is going to be supply based, whereas NSIL is going to be demand based. NSIL will be demand based and Antrix will be supply based. And this is exactly what the government had said. Now, the reason, the meaning of what is supply based versus demand based. Supply based is when you are supplying something that you already have. Just suppose, just take Antrix like a normal, any general store or any supermarket that you go to, that you can only buy the things that's already there. You cannot demand for something, correct? If they don't have something, they can't give it to you, right? So that's what you call as supply based in case of Antrix. So Antrix will deal with anything, any technology, any let's say uh, component or any service that ISRO already has, that ISRO already provides. So, for example, suppose that there is some sensor that ISRO has made, and there is one space agency that wants to buy it from ISRO. So, because it already has been done, it's already there with ISRO, then Antrix will take care of it. And if it is a new request that somebody comes to India and says that, can you do this for us? And then if India takes that as a project, then that's the role of NSIL. All right. So this is where the difference lies between what is supply based versus what is demand based. This is how the difference in their roles is supposed to be seen. And NSIL altogether will now start working towards the entire development of the space market in India. That's why even the operations of SSLV has been given to NSIL, is being looked after by NSIL. And apart from these two, there is this another important unit that was added, that is InSpace, Indian National Space Promotion and Authorization Center. Now, this InSpace was added in 2020. Until 2020, even this did not exist in this organization. Now, when it comes to the role of InSpace, the role of InSpace is largely about the to provide support and authorization of the private entities in the Indian space sector. All right. So the private entities, the private players who are there in this Indian sector or Indian space sector, InSpace is going to help them. All right. InSpace is going to help them. So that is what InSpace is. So that's why InSpace along with NSIL, these two become responsible to develop this entire space sector or the private market in the space sector in the country. So that's why they are also helping a lot of startups, a lot of different projects are being given to other companies, and they are trying to create an entire environment about space sector in India. So that's why their roles become very, very crucial in this given scenario. Now, when you look at all these ISRO centers, you'll find that the ISRO centers are placed all over the country, but largely you'll see that a lot of these sectors, a lot of these units, they're all located at Bengaluru. And the reason for that is, first and foremost, the launches have to happen here. Launches have to happen from Sriharikota, which is in Andhra Pradesh. So you cannot have your centers in Delhi or in North India and then communicate from here to here. Operationally, logistically, it becomes a big challenge. So that's why a lot of these units are all present in the southern part of the country. So, for example, let's say the LPSC is in Bangalore, then ISAC, or what is URSC, is in Bangalore. The headquarter is in Bangalore. The Space Commission is here in Bangalore, and then after that, some of the other sector centers like NRSC is in Hyderabad. Then the launches are done from Sriharikota in Andhra Pradesh, and then we have the Vikram Sarabhai Space Center in Thiruvananthapuram. So in this manner, you'll see that largely the distribution is in south, and only one, that is Space Application Center, is located in Ahmedabad. Apart from that, and anyway, there only smaller components and sensors are being made, so it is not going to make an operational challenge for us to operate from there. So that's why we see that a lot of distribution of these are all done in the southern part of the country. Now, when it comes to the launch, what we understand is that in case of the launches right now happen from here. This is where you have Sriharikota. So the launches are basically carried out from here, that is in Sriharikota. Now, apart from that, there is work going on second launch pad that is also being uh, made by ISRO, and this was again a news of October 2023, where we see that there is a new spaceport that is being constructed by ISRO, and this is being done at Kulasekarapatnam in Tamil Nadu. Now, when it comes to Kulasekarapatnam, also understand the value of this place. That why have we chosen Kulasekarapatnam? Now, overall, when we do launches, any launch that we do, there are two aspects of a launch that you will always notice. That first, the launches are also always done. Launches are always done eastward. The launches are done always done eastward, and launches are always done near the equator. So launches are done near the equator and the launches are done eastward. These are 2 points that you'll always notice about any launch that happens anywhere in the world. Now also understand why. Why are the launches done eastward and why are the launches done near the equator? Can you think of a reason, or if you know the reason, can you tell me first? If you don't, I'll anyway tell you. But first, I want to know from you. What do you think? What's the reason? Why do we do the launches eastward? Yeah. So Kola, Jayant, Shikha, Hemlata, Shakti, Himanshu, all of you have given the correct answer. Vishal Jia. So everyone, so many of you know, that's wonderful to know that launches are done eastward largely because we know that the rotation of the earth happens from west to east. So to use that rotational speed, because the rotation is happening from west to east, we launch eastward. So that would mean that we'll be able to gain that speed. We'll be able to gain that speed of rotation of the earth. So that's why the rotation, to gain that speed, the concept of relative speed works here. So to gain that speed, we do the launches from eastward, or we do the launches eastward. So that's why eastward launches are done. So eastward mainly because as the earth rotates from west to east, eastward launch would help decrease the effort required in launching. All right. And then the second point, why do we do the launches near the equator? So already a couple of you have given the answer, but wonderful. But others, do you know the answer? Why do we do the launches near the equator? So Shiv, you have given the correct answer. Yes, Vishal, you have given the correct answer. Gia, you have given the correct answer. Pulukonda, you have given the correct answer. So in this particular scenario, when it comes to being near the equator, rotational speed of the earth is the highest at the equator. All right, so this is where rotational speed of the earth is the highest at the equator, and that's why we can gain the speed easily with less fuel requirement. We can gain the speed easily, and that's why the launches are done near the equator. So that's why you'll see that not only for India anyway, good thing for us is that we are near the equator. We are not exactly at the equator, but at least near the equator, so makes our job easier. And for many of the other countries, you'll see that they have either they choose an island nation, or they have some kind of agreement with some nation which is near the equator, so that they can do their launches from near the equator. So it's not that you cannot do a launch from a temperate region or from the polar region. You can do the launches from there on also. But if you are at the equator or near the equator, you need less effort in doing your launch. And that's why many of the other countries, they have chosen some of the island nations near the equator, or maybe any other country. And that's why you'll see that the launches are done from eastern coast. Launches are always done eastern coast. Why eastern coast? The reason is very simple. The reason is not physics. The reason is very simple. Why do we choose eastern coast for the launches? Why not western coast? Why not Maharashtra or Karnataka or Goa or Kerala? Quickly, anyone who knows the answer? Why to choose east, not the west? Yes, Anu, you are correct. Jia, you are correct. So largely this is mainly for the fact that you are going to launch all your satellites eastward. Correct? The satellites are about to be launched eastward. Now, suppose you choose a western coast and you do your launches like this. Then it means that you are going to fly over the Indian landmass, which is a potential security concern. So that's why we wouldn't choose western coast. We would always choose eastern coast, because from here you'll be flying like this, or maybe like this. So when you fly like this, you are flying over the sea, over the oceans, and then there is no chance of any impact on human life, or any security concern it wouldn't create. So that's why we need to understand why we choose eastern coast instead of western coast. It's simple. It's just security reasons why we do that. Now in this particular scenario comes Kulasekrapatnam. Now why to choose Kulasekrapatnam? Because when we want to launch towards the equator from Sriharikota, we cannot go like this. Correct? We can go like this, we can go like this, but we cannot go like this. Why? Because Sri Lankan lives also matter. It's not only Indian lives that matter. So flying towards the equator would mean that you would have to fly over Sri Lanka. So that's why the path that is taken is southeast. So instead of taking southward path, we take a southeast path. So that also means that you have to take a longer distance to go near the equator if you want to. From Kulasekrapatnam, that's not the case. it's easier because you are automatically avoiding the Sri Lankan landmass. So that's why Kulasekhara has been seen as one of the potential where another satellite launch pad can be constructed by India. Now we come to the last topic of our discussion, and this is about space debris. Now, space debris basically is anything that is man made left by us in space. Anything that we have left in the space uh, is called as space debris. So it could be either dead satellites or bigger objects, or maybe something that has broken off from the satellites, or maybe very small fragments of these satellites, even paint specks sometimes that come out of the satellite because of the velocity at which it is traveling. So all that will be called as space debris. Now, the problem with space debris is that the number of space debris has been increasing, because every year we see that the number of launches that we are doing is also increasing. So, our overall number of launches, not only in India but worldwide, has increased over the years. So, that's why we see that this becomes very, very crucial for us to now understand the problem of space debris and what is happening now, and how it can become a serious concern in the coming days. So space debris overall, if you look at the data says that 65% of all the space objects are non-functional objects, and there are only 7% of the space objects which are functional satellites right now. And there are 28% of nothing but small fragments of space objects that are lying in the orbit. So from there on, what we see is that these space objects may start to become a challenge for us, because if you consider some data, it says that there are almost 4,000 active satellites in the Earth's orbit, 3,000 dead satellites, 34,000 pieces of space junk which are larger than 10 centimeters, and 128 million pieces of space junk which are larger than 1 millimeter. So that's why these space debris, these numbers, this also mean that we are increasing this problem, and this is becoming a bigger threat day by day. And that's why in that context, for us to also understand what it can do in the future, where there is a concept which is called as Kessler syndrome. Now what this concept of Kessler syndrome says is, and this was an idea that was proposed by NASA scientist Donald Kessler. Now what he proposed as an idea is that there could be a scenario in the future where you have used this so you have used the orbit so much that there are a lot of space junk that is there in the orbit. So he said that if there was too much of space junk in the orbit, it could result in a chain reaction where more and more objects collide and create new space junk in the process, to the point where Earth's orbit became unusable. So what may happen in the future, what he proposed as an idea, that what may happen in the future is maybe two satellites collide, because there are so many satellites now. Maybe there are two satellites that collide, or maybe a satellite that collides with a space junk. And as this collision happens, it creates more space junk, right? It creates more space junk, and all this space junk will keep on colliding with other satellites, and it becomes a chain reaction, and this keeps on increasing to a point to an extent where this entire orbit becomes unusable. And this is an idea that he had proposed back in 1978, and today we see that this is becoming a reality, because now more than ever the number of satellites that we are launching is very high. And in that given scenario, it becomes very, very important for us to also understand the value uh, of what it can do. It would simply mean that we might not even be able to use the low Earth orbit, especially in the coming days. So that's why we need to be aware of this situation, and we need to act on that situation. And some of the scientists also say that the low Earth orbit is the biggest waste dump that we have around the earth. Or even if you consider the earth, on the earth also you do not have such a big waste dump as much as the low earth orbit has become. And that's why we are looking towards various solutions today to clean up the space junk and look at various solutions to clean the space junk. So for example, India has a project that we have been working on, and this project is called as Project Netra. Project Netra. Now, this Project Netra basically is about tracking, tracking of Indian space debris. This is about tracking of the Indian space debris. So that's why Project Netra. Netra means what? Eye. So it is something that is keeping an eye on all the space debris created by India. Now, apart from that, what we see is that when it comes to this project, that is Project Netra, apart from Project Netra, if you look at some of the other uh, countries and their space programs, they also have been working on various ways in which they can also reduce their space junk. So for example, there are some missile technologies that US has been working on or NASA has been working on, so that they can just push the bigger objects, bigger space debris out of the low earth orbit. Then Japanese space agency or JAXA, they have been working on a concept which is similar to a fishing net, where they'll simply collect all the space debris that they are creating. But overall, we know that there are all these various ways, various technologies that the world has been trying, so that we can clean up the low Earth orbit. Otherwise, there could be a possibility that Kessler syndrome can become a reality. And if that happens, low Earth orbit at least will become unusable for us. The problem is not so much with high Earth orbit, because first and foremost, high Earth orbit is a much bigger space, right? It's a much bigger space. So that's why the debris being created here are not going to be threatening as of now. And similarly, at the same time, the number of satellites also that we launch to the high Earth orbit or the geostationary orbit, they are not many. All right, they are not many. So that's why, in that sense, high Earth orbit is not a bigger challenge. But in case of low Earth orbit, we see that this has become a big problem, and that's why there are various solutions that everybody now has been working towards. If you look at the number of space debris created by everyone, the top three countries have been Russia, United States, and China. And compared to them, other countries do not have such large numbers of space debris. So that's why the count with regards to their space debris contribution is higher. And that's why these are the countries which are also trying very hard to come up with solutions so that they can reduce the number of space debris that they have created. So overall, this is about the chapter. Now we discussed about a lot of prelims based questions, and based on every topic that we came across, looking at the mains examination and the topics that have come in the mains examination, the various things that have been asked, just also let's try to understand what kind of questions. And in the last class, I had also told you, when we were discussing the strategy for science and technology, I told you that the questions that you get in the mains examination are comparatively easier as compared to the questions that you get at prelims level. There are 3 to 4 questions that we expect in the mains examination from science and technology, out of which I would say almost every year one question does come from space technology. So that's why, from that perspective, it makes space technology especially important, because we see that almost every year a question comes. 2023 a question has been asked, 2022 a question has been asked. Only 2020 and 21, you can say the COVID years, is when questions were not asked from here, but one question asked on COVID-19 and other topics were asked. Otherwise, you'll see that every year at least one question is what they ask from a space technology. So if you look at the first question here, as in 2022, launched on 25th December 2021, James Webb Space Telescope has been much in the news since then. So this is nothing to do with the question yet. Then comes the first question. What are its unique features that make it superior to its predecessor space telescopes? So that's the first question. What are the unique features that make it superior? Second question is, what are the key goals of this mission? So key goals of this mission, and what potential benefits does it have, does it hold for the human race? So these are the three questions that they have asked you, and overall you had to write this answer in 250 words for 15 marks. So when it comes to this kind of a question, first you will start with a basic introduction about what is James Webb Space Telescope. So you'll write about that, and you should not use more than 40 words, maximum of 40 words, let's say 30 to 40 words, and then start with all these parts of your answer. So first will be about what are the unique features that make it superior than its predecessors. Now in case of its predecessors, we talk about one telescope particularly, that is the Hubble Space Telescope. Up to an extent also another telescope, that is the Spitzer Space Telescope. So these are two telescopes which can be called as its predecessors. And when we look at the James Webb Space Telescope, there are particular features that make it very important. First, it is an infrared telescope. So, infrared telescope means that it will be able to take pictures and images that other telescopes haven't been able to take yet, because infrared rays are longer and they can travel longer distances. How exactly all that happens will you'll understand when we go to IT and communication chapter. So that's one thing. Second, it has been placed at L2, whereas when it comes to the Hubble Space Telescope, Hubble Space Telescope is in the low Earth orbit. So that's why uh, James Webb will be able to take better pictures. It will be devoid of any radiations or any light or strong source of any uh, electromagnetic waves from the sun. So that's why it will be able to take better pictures from that matter. And then there are other instruments on board that also add to the value of James Webb. So that's a unique features. And then what are the key goals of the mission? So key goals of the mission is to identify space objects that we might not have seen yet, also to look at stars and galaxies from the early universe. A very very important key goal is to look at the early universe and try to understand what happened in the early universe, whether all the theories that we have, whether they are all correct, or is there something different that we observe. And then the potential benefits. So potential benefits is that it can give us a better insight towards the origin of the universe, origin of the earth itself, origin of the solar system. And at the same time, for the future, it can also help us in better understanding of even the technology, and that technology further can be used in the future in various different aspects and various programs. So that's why there are all these. So try that, because there are three questions, try that you have three different segments in which you are answering your question. So this is where you will almost, you for the body of the answer, you will have to give up to 150 words here. So 150 to 170 words here, let's say 50 words each in all these three. And then finally when it comes to the conclusion, in case of conclusion, again let's say 30 to 40 words you'll keep for the conclusion, and talk about that there are already you talk about what already has been happening, that they already have given you some information, some insights, and some of the images, etc. So all these things can be written here. Then the second question: what is India's plan to have its own space station, and how will it benefit our space program? So, what is India's plan to have its own space station, and how will it benefit our space program? Now, this question was asked in 2019, because in 2018 it was in the news that India, first it was some rumors about that maybe India is joining the International Space Station, but then India clarified that no, we are not joining the International Space Station, but rather we are working on our own space station. We are working on our own space station, and this space station should be will start working on the space station after the Gaganyaan mission. This is what basically India had said back then. So this question basically is based on that. So this is what the plan is, that we want to start working on our own space station after the Gaganyaan mission. Now, how does it benefit our space program? Couple of things that we should understand here. First, what is the role of any space station? You can take the hint to the answers to this question from the space station, that is the International Space Station. Now, first, it is a place from where we can do a lot of experiments, a lot of microgravity experiments, a lot of experiments about the biology of various organisms, whether plants or animals or humans. We have seen all that. Better understanding of the space environment is what we are looking towards. So there are all these things that can be done with the help of a space station like this. At the same time, it can also become a support module for our satellites, especially the satellites that we have in the low Earth orbit. It can also function as a support station for all these. So that's why it will have a lot of these benefits for our space program. So this is what this question has asked. Then the next question, if you see, why is Indian regional navigation satellite system needed? How will it help in navigation? So again, you can say more or less it's the same. It's a question that we discussed anyway. That what is IRNSS? We discussed about this. Why is it needed? We discussed the history and the present of it, and how does it help in navigation. You can also talk about how uh, we discussed about triangulation. If you can mention that this is how technically they use the method of triangulation to help in navigation. And then after that, various applications that we see, and how it will be able to help us in timing, in positioning, in providing the location services, etc. So something very simple and something that we have discussed already. Then, if you look at the next question, India has achieved remarkable success in unmanned space mission, including Chandrayaan and Mars orbiter mission, but has not ventured into manned space missions, both in terms of technology and logistics. Critically, explain critically. So, what are the challenges? What are the technological and logistical challenges that we have in launching such a human space mission? Now, when it comes to the challenges, there are two things that you have to understand here. That from the perspective of what we have done, technologically, there are a lot of things that we have to think of. That how do you create the crew module? How do you ensure the safety of the crew module? What kind of helmets do you need? What kind of space suits that you need? Training has to happen. The training happened in Moscow for the people who are going in as a part of the Gaganyaan mission. So there are all these things, the food, the biology. We need to understand all that before launching this mission. So technologically, these are the challenges. And then logistically, the challenges when you look at. So logistically also we understand that there are a lot of challenges. Operationally managing it, also the financing of it is not going to be that easy, correct? Financing is not that easy. The budget that you need for this thing to work, for example, the budget of the Gaganyaan mission is more than 10,000 crores. 10,000 crores. So that's a huge amount of money, correct? It's a huge amount of money, and that's why we need to also understand the value of that money in regards to this mission or any mission like this. So these have been the reasons why historically we have not taken these efforts. And now that you can say in a manner our space program is very stable compared to where we were 10 years back or 20 years back, now we can start moving in this direction where missions like the Gaganyaan mission can be made a reality. So that's why you have to write about all these things in a question like this. Then the next question, if you see, discuss India's achievements in the field of space science and technology. How the application of this technology has helped India in its socio-economic development. So first part is about India's achievements in the field of space science and technology. And the second part is about how it has helped in socio-economic development of the country. So these are the two questions that we have here. Now, when it comes to achievements, there are two ways in which you can write achievements. Either you can write sector wise, either you can write sector wise, or you can write it chronologically. Either write it sector wise, that these are the things that have happened in earth observation, these are our achievements in communication satellites, these are the achievements in navigation satellites, these are the achievements in the manner how it has helped in employment generation. So there are a lot of things that you can write here, how everything has come up, and then either if not chronologically, in 1960s this happened, 1970s this happened, 1980s this happened, 90s, 2000s, 2010s. So in this manner you can write about it. So these are the two ways in which you can write, and both are correct. You can use one of the two depending on what you are at ease with. The second part is about how it has helped India in its socio-economic development. Now socio-economic development, when we look at, then you have to think of agriculture first, that how it has helped in agriculture, how it has helped in increasing the agricultural productivity, so that farmers also get out of it, people at large also get benefits out of it. So how it has helped in getting us better in agriculture. Then after that you can also write about disaster management, and how it helps in disaster management, how it is able to save lives and save properties in case of having better disaster management mitigation strategies. Then communication, that how the revolution in communication has happened because of communication satellites, whether it is mobile phone or internet, all these things are all thanks to the communication satellites. So space technology has helped in that. So there are all these points that you can mention in a question like this. Then if you look at the last question that we have here, what do you understand by standard positioning system and precision positioning system? Now this in the GPS era, so this is something that we have discussed in terms of IRNSS also, that there is standard positioning service and restricted service. So that restricted service is nothing but, this is what we also called as restricted service. So we discuss about both of them. So you just have to mention that. Discuss the advantages that India perceives for its from its advantage ambitious IRNSS program. Again, the same question: the benefits of IRNSS and where we can use it. That's it. So it's again a simple question and something which is based on what we already discussed. So these are the questions that have been asked from space technology in your paper. Before we move on to biotechnology, our next chapter, if you have any questions, if you have any questions with regards to all this, and if you have any further query, I had given you my email ID last week also. You can drop an email to me at rashesh.kumar at byju's.com. Sandeep, if you can drop an email to me about your query, I probably can help you better. I can get in touch with the support team for this. In Rocket Boys, there was reference to Thumba. Thumba basically was, you can say, the first launch station or launch pad that India had, a small launch pad which was in Thumba in Kerala. And this is where very many experimental launches were done in the initial days of India's space program. So in 1960s, largely 1962, I think was when for the first time we did a launch from Thumba, and for the next few years we kept on doing it unless we until we started getting into bigger launches. This is where we shifted thumba to uh, from Thumba to Sriharikota. Actually, a wonderful series to watch. I mean, for those of you who haven't, but you, I mean, I wouldn't recommend that you leave everything and start watching a series right now. It doesn't help you with science and technology because it's also partly fiction and partly based on facts. email ID even for answers. I mean, if you have submitted, you can submit to ieslive@byju's.com or targeties@byju's.com. Yeah. So if no more questions, we can move ahead. Right. So we'll do a basic introduction to biotechnology, and then we'll take our lunch break, and then after that, uh, on the other side, we'll keep continuing with our discussion. So for the next 10 odd minutes, we'll just discuss the basics of what is biotechnology, and then after that, we can take a break. So biotechnology, first from the perspective of your prelims and mains examination, this is a topic that again, just like the last two topics, just like the last two chapters, has been important for prelims and mains. And every year in prelims, at least we see that at least one question, if not more, comes from biotechnology. So that's why from prelims perspective, definitely a question is asked every year. In the mains examination, almost every year, every second year, they do ask a question in the mains examination also. So that's why it has its relevance in both your prelims and mains examination. Although as a chapter, it is not as big a chapter as the other two chapters were. And now onwards, we do not really have any chapter which is as big as the first two chapters were. Now, biotechnology. If you break down the word, there are two parts to it: biotechnology. Now, bio comes from the word bios, which is a word in Greek which means life or anything that is living. That's why when you talk about biology, biology is the study of the living. So that's why the term biology also comes from bios. Similarly, biotechnology, again, we are talking about the living, right? We are talking about the living. Technology. What is technology? Okay, we are talking about science and technology. Can you tell me what is technology? What, according to you, is technology? Application of science, something that makes work easier, enhance the way of life. Okay, all these are correct answers, but by definition, by the exact definition, technology, you can say, is nothing but the application of science. Application of science. So what, as you can see, what we are discussing, for example, in energy chapter or in space technology chapter, or even in biotechnology, we are studying something related to the basic sciences. In energy chapter, it was largely about chemistry, that various applications of chemistry is what we discussed at a higher stage. In case of space technology, it was largely physics. We basically discussed various applications of physics. And in biotechnology, it will be biology. So in a manner, there are applications of biology that we are going to discuss in this chapter. So that's why when you apply science in one way or the other, you can say that this is technology. And then it is something that also helps us make our life easier, also adds to the value of life. It also makes the job easier in a lot of ways. So we see that um, how this is how technology is. So when we say biotechnology, the meaning of biotechnology is the use of living organisms or any process in these living organisms for one application or the other for the humankind. So if the humankind can be helped with if the humankind can be helped with the help of any living organism or any of their processes, then in that case it is called as biotechnology. So that's why bios basically coming from biology, and technology talking about technological applications of or application of science, and defined as the application of living organisms and their biological processes in order to make the best use of living organism for the benefit of mankind. Now, when we say living organisms or their applications for the benefit of mankind, what exactly do we mean? A simple example of the use of biotechnology is curd, making curd from milk. Now, how do you make curd from milk? You take milk, you take just 1 spoon of curd, and you add that 1 spoon of curd in milk. What happens next? There is a bacteria in this curd called as lactobacillus, and it starts reacting. It basically starts multiplying when it is in milk, and it starts converting milk into curd. And so the only thing that you have to do to make curd is that you take a bowl of milk, put curd in it, just leave it overnight. Next morning, milk would have converted into curd, and that is happening because of the action of bacteria which were there in curd. So then in that case, we see that in a manner you can say that this is what application of biotechnology. This is nothing but biotechnology, because you are using a living organism for an application, and here the application is food. Similarly, there are other examples, like let's say even making bread, where you use yeast. So the use of yeast in making bread is also biotechnology. Preservatives that we have used for hundreds of years, many of these are natural preservatives where you are using maybe some plant, or maybe some part of the plant as a preservative, or maybe some kind of product coming from here, from a living organism, largely a plant. So that's why again, it is nothing but biotechnology. The use of alcohols, how the use of alcohols, when we have used fermentation, where we have understood that some organisms can be used in the process of fermentation. So that fermentation process is also nothing but an application of biotechnology. And making alcohols, I mean, goes if you go back into history, we learnt making alcohol before we learned how to make curd. So humankind always has had its priorities straight. So first we understood how to make alcohol, and then later we realized that okay, oh, a similar process can be also used for making curd. So first came alcohol and then came curd. But when we talk about the modern biotechnology is very different. It's not based on some hit and trial, right? Fermentation might have been a case of hit and trial. Making curd from milk might have been a case of hit and trial. But when we talk about modern biotechnology, here it's not hit and trial. Here, everything that we are doing is being done for a reason, right? We are making the use of DNA. We are making the use of genes. So now, what these genes are, what this DNA is, we did not really know of it practically. We understood that there is something. For example, there are Mendel's experiments that happened more than 200 years back, where he talked about some factors, that there are certain factors in the plants where we see that these characters are happening because of these factors. So there are mentions of all these, but in 1950s we understood what is DNA. We discovered the DNA and we understood what is the DNA, and this is what starts the branch of biotechnology. This is where the branch of biotechnology starts taking a shape, and that's why biotechnology becomes a very very crucial branch from here on. And that's why I said that when we talk about modern biotechnology, it's different, because until now whatever we were doing, we did not know what we were doing. It's just that something clicked and something worked and we started using it. But after the understanding of the DNA, this is where we see that modern biotechnology starts taking shape. Now, that is where we also have to understand what do we mean by what do we mean by DNA, or what do we mean by genes, and what do we mean by chromosomes, etc. Because we are going to use all these terms in this entire chapter will keep mentioning the words genes or DNA or chromosomes in one way or the other, whether looking at medical applications or agricultural applications or industrial applications, or what is gene therapy, or what is stem cell therapy, what is cloning, what is the case of GM mustard, what is the case of three parents baby. So we'll keep discussing all these things, and this is where we'll see that all these things will come into the picture, but the basic understanding of DNA, genes, and chromosomes will be required. One more thing, uh, in this particular chapter, if you look at your past prelims and mains papers and the way the questions have been asked from biotechnology, you will see that in mains examination the questions are very simple, mostly application based questions. We'll discuss that towards the end, but very simple questions. But in case of your prelims examination, you will see that the questions are, there are two ways in which they ask your questions. Either they are asking you direct uh, concept based questions based on the basics of biotechnology, or many a times, and you'll notice that almost every year in your prelims paper, that they ask word based questions. Now what I mean by word based questions is that they'll just give you a word and they'll ask you a meaning. And almost every year biotechnology questions, you'll see that they have just asked you a word and they have asked you the meaning of that word. And most of these words are, I mean, there are a lot of words that we are going to discuss in this chapter. You'll keep coming across a lot of new technological terms. What I want you to know is that if you understand the meaning of this word, even in just one sentence, even if you understand the meaning of this word, just the definition of the word would be enough for you. Even in case of current affairs, you come across a new word related to biotechnology, just look at the dictionary meaning of that word. No need to know the technicalities of it and everything behind it. No, in one sentence you can, if you can just understand what that word is, that will be enough for you in the prelims examination, because a lot of questions that they have asked, it all has been based on a basic understanding of that word. All right, so that's why I just want you to understand all these things before we begin and before we move on. So the time is 2:45. Let's take a break here. And on the other hand, we'll start on the other side of our discussion. When we come back, we'll start from here. We'll start from understanding of what do we mean by DNA or genes or chromosomes and all these things. And then we'll move on to all the branches of biotechnology one by one. All right. So let's take a small, not a small, rather a longer break here, and let's take our lunch break. I think the next, if I'm not wrong, the next link, the part two, starts at 3:40 p.m. if I'm not wrong. So let's be back by 3:40 and have a discussion on biotechnology. Any questions if you have anything that you want to ask? Any question if you have from whatever we have discussed? Should we also learn about NASA for exam? I wouldn't say that. See, only some of the missions which are widely discussed, and the missions which have a wider application in space science, something which is unique, something which is new, only then you have to study about those missions. Otherwise, nothing. I mean, you don't have to learn about NASA and what NASA is supposed to do and all that. No. Only some of the missions which might seem to be more crucial from the perspective of examination than others, if these are unique, if these are being done for the first time and we have never seen this, then only. Otherwise I wouldn't say that. Your teaching skills is very good. Thank you, Anu, for the compliment. These are the things that keep us running while taking the classes. Ramavat, I think technically we wouldn't be able to start at 3:40 p.m. because when the link is generated, it is generated in a manner that we can only do it when uh, the link time starts. Before that, it's not permissible by the system. All right. So if you have further questions when the new link is generated and when you join there, you can ask those questions there, and we'll start with the remainder of this chapter once we are back.